In this lesson, we continue exploring Power BI data modeling by focusing on relationship between the tables. You learn the different type of relationship cardinality, how filtering works, how to avoid many-to-many relationships, and how these concepts support building a clean star schema data model in Power BI. Let's dive in.
Let's go up again. So what was it? Data model is two or more data sets connected via relationship. We have data sets. We have kind of broken down so these are the two important elements. Now you know about the data set. Let's break down relationship a little bit. Let's break down relationship. What are the two important elements of a relationship? We discussed it briefly yesterday. We call it cardinality. You might not be aware of the terminology, but you will get what I mean by cardinality in a sec. And then you have cross filter direction. Cardinality is one to many, right? Many to one to one, and many to many. These are the four types of cardinality we have. Which one is the default cardinality?
One to one.
Default. No, these two. One to many and many to
One to
one.
many.
Correct. It's actually the same thing. If you're looking from the dimension to the fact, it's one to many. If you're looking from fact to dimension, it's many to one. This is your default. Okay, one to one. I have a very strong opinion on this one. Whenever you have a one to one, just merge it, make it a single table. It will make it simple for you. A lot of the data modeling is how can I make the model simple for my understanding? You just merge it. A lot of one to one happens across same dimension table, right? Another principle that I follow most of the time is if I have a single dimension, let's say a product dimension, I just consolidate that into a single table. If I have a client dimension, I consolidate all the relevant columns that links to a client ID into a single client table. Just by understanding this categorization of a fact in the dimension table, you start to know, okay, I'm going to combine a single dimension into a single table, but I'm not going to combine dimension with the fact table. So you know when to merge and when to stop. Okay, what about many to many? You're also going to see an example. Caution, right? Caution because majority of the time, at least in my experience, majority of the time, many to many is a result of duplicates going unnoticed. You have duplicates you don't know, and you will do a bad job with data transformation. You will have a duplicate, you don't notice it, and that results in many to many, and it will cause some future reporting problems. If you're sure that you do not have a duplicate in both the data set, many to many is a legitimate relationship. In old days, when Power BI was old and weak few years ago, there was no many-to-many relationship. We had to create a bridge table to solve this problem. But now, many-to-many exists as a relationship. It's a legit relationship. Power BI will give you a warning, so you are sure it is a genuine many-to-many relationship. If that's the case, by all means, go for it. So just be cautious. Let's have a look at cross-filter direction. Here, we have two values. We have a single and then we have a both. Your single is your default. Both, all I can say at this point about both, use it rarely when you know why you use it. This is all I can say at this point because what happens is people start to use both as a default relationship. When you start to use both as a default relationship, it opens up your model for a lot of circular referencing down the line. Because now every table is talking to every other table. My fact table can filter dimension and my dimension can filter me back. So when I start to connect multiple tables like this, it gives you a lot of problem of circular referencing. You cannot connect more tables because now every table can talk to each other. So use it really when you know why are you using it. This is the normal behavior where I see people start to use both. They are working on the report, and I think someone also had a question that their matrix is not working, right? And what they normally do is this, their matrix is not working, and then they will go back to the data model and then they will start to hit and trial with the relationship. They will make it both and they will change the relationship and suddenly the matrix is working and they just solve it by hit and trial, not really thinking it through why something is happening. Use it really when you know why you use it, right? What is the purpose of using both? Majority of the time, 99% of the time, single will solve the problem. Okay, let me stop here now. Please ask any questions that is not clear to you. Yes, Jeff,
Could you
please go on.
just go back to the star schema and just cover that again really quickly?
Yeah, sure. So star schema is basically star schema means your fact table is connected to your dimension table. When you can create dimension tables properly, eventually it will actually result in star schema anyways, right? So the only thing that you have to take care and few things that you cannot, the rule that you cannot break is you can only have one active relationship between two data sets and you cannot have a circular referencing. It's not something that you can do anyways, but just by knowing these rules, you are going to understand that when inside the data modeling, Power BI will throw an error. Why is it throwing an error? Because you are breaking a star schema rule. And the error message would be something like this. You cannot connect these data sets together because it will create ambiguity across table number one and table number two. And when you will really start to notice it closely, you will see, okay, this table and this table is connected by this table connecting to this table and this connecting to this one, this one, this one, and this one, right? You will be able to track that relationship across, but it will not be that easy to see.
So you're really just describing a relational database structure.
Yes, correct. It's a relational. I would not call it a database because,
No, I understand. I understand why you're not calling it a database, but
but the
that's really what you're
principles are same.
describing. Is yeah. Okay.
Principles are the same, correct? Okay, so based on this, there are a few things that I would highlight, which is um, if you have a single dimension table, let's say in our case, we have a product table and our product dimension is broken down into four tables. I would actually combine a single dimension into a single table most of the time because it simplifies my data model. But I will not bring it back inside the fact table. Okay, so I think for now, this is enough with the theoretical aspect. Let's start working on the data model.